Hello everyone, welcome back to KS Math Academy. This session is Part 2 Integral for Class 12 CBSE. The video link for the Part 1 integration is given in the description. Now look at the problem. Integration of x dx divided by x square plus 1 into x minus 1. So this can be treated as I is equal to. So let us assign our value x divided by x square plus 1 into x minus 1 can be a divided by x minus 1 plus bx plus c divided by x square plus 1, because here we are having x square, and then you can take LCM the left side and right side. So here x square plus 1, so a times x square plus 1 plus bx plus c times x minus 1, and left hand side we are having this. So you can cancel your denominator part. Now x is equal to a times x square plus 1 plus bx plus c times x minus 1. By comparing the coefficients, you can find your value of a, b and c. So our a value is 1 by 2, b value is minus 1 by 2 and c is 1 by 2. Now substitute your values in this. So I is equal to integration of, you can split your integration also. So 1 by 2 into integration of dx by x minus 1 and minus 1 by 4 times integration of 2x divided by x square plus 1 dx plus 1 by 2 into integration of dx divided by x square plus 1. Now you can do your integration. So 1 by 2 log of modulus of x minus 1 minus 1 by 4 into log of modulus of x square plus 1 plus 1 by 2 times tan inverse of x plus c. So this is our answer. Moving on to the next problem. Integration e power x square times x power 5 plus 2x power 3 dx. This can be written as e power x square into x power 4 2x square. Take your x outside, x dx. Now substitution procedure, t is equal to x square. So dt is equal to 2x dx. So now this is, we need x into dx. So dt divided by 2 is x into dx. Now substitute your value. So integration e power t plus t square plus 2t into dt divided by 2. So you can take your 1 by 2 into e power t into t square plus 2t into dt. Now we know the formula, e power t formula. So integration of e power t into f of x plus f dash of x dx is equal to e power x into f of x. Now look at here. So this term f of x is our t square and f dash of x is our 2t. So you can write your answer as integration answer as 1 by 2 times e power t into f of x value is t square here, t square plus c. Coming to the back substitution, 1 by 2 t will be taken as with our, here t will be taken as our x square. So 1 by 2 e power x square into x to the power 4 plus c. So this is our, read the next problem. Integration 1 to 3 root of 4 minus x divided by root x plus root of 4 minus x dx. Consider this as your equation number 1. So here we are going to use our formula, that is integration a to b f of x dx will be equal to integration a to b f of a plus b minus x dx. So this is our pattern. So we can use this formula here. So now we can rewrite our equation as 1 to 3 root of 4 minus of 4 minus x, 3 plus 1 minus x. So 4 minus x divided by root of 4 minus x plus root of 4 minus, instead of x we are going to write 4 minus x dx. So simplifying this, integration 1 to 3 root of 4 minus 4 cancel, then plus x. So root x divided by root of 4 minus x, and similarly here also we are getting root x dx. So take this as your equation number 2. Now you can add these two equations. So left hand side we are having I. So I plus I is equal to 2I. So 2I is equal to, in the right side part, the numerator here in the first part we are having root of 4 minus x. In the second part having root of x. So root of 4 minus x plus root of x. Denominator part is common. So root of 4 minus x plus root of x dx. Now these two items will get cancel each other. So integration 1 to 3, 2 times I. Integration 1 to 3 is 1 into dx. So this is 2I is equal to x with the limit 1 to 3. So 3 minus 1, 2. So 2I is equal to 2. So I is equal to 1. 2 divided by 2, which is equal to 1. So this is our final answer. Look at the next problem. Integration dx by x square minus 6x plus 13. The denominator part can be done with the completing the square procedure. So this will be x minus 3 the whole square plus 4. So this can be x minus 3 the whole square plus 2 square. Moving to the integration part, integration of dx divided by x minus 3 the whole square plus 2 the whole square. So now this is a value is 2 here. So 1 by 2 into tan inverse of x value is x minus 3 divided by 2 plus c. So this is our final answer. Read this question. Integration 0 to 1 x into 1 minus x to the power n dx. This is a famous question. So here again you can take your data as you can supply your property, that is integration a to b f of x dx will be equal to integration f of a plus b minus x dx. So a to b. So this property we are going to use here. So integration 0 to 1 x into 1 minus x to the power n dx can be written as 0 to 1 x will be 1 minus x, and here in within this 1 minus of x will be again 1 minus x to the power n dx. Using the property we are writing like this. So 0 to 1 1 minus x, and within square bracket you take minus inside. So 1 minus 1 plus x to the power n dx. So 1 will get cancelled. So x will be there. So integration 0 to 1, 1 minus x into x to the power n dx. Now you take your x to the power inside. So 0 to 1 x to the power minus x to the power n plus 1 dx. Now apply your power rule here. So x power n plus 1 divided by n plus 1 with the limit 0 to 1, and minus second term is x to the power n plus 2 divided by n plus 2 with the limit 0 to 1. Now applying your limit here. So 1 divided by n plus 1 minus 1 divided by n plus 2 we are getting. Or if we take LCM n plus 1 into n plus 2, so then numerator value will be equal to 1. So this is our final answer. Moving to the next question, evaluate integration 0 to 2 pi modulus of sin x dx. And we know very well the sin x is positive in the interval 0 to pi and it is negative in the interval pi to 2 pi. So we can write our modulus of sin x can be this way. So positive of sin x in the interval 0 less than or equal to x less than or equal to pi, and negative of sin x in the interval pi to 2 pi. So we can split our integration. So this is 0 to 2 pi can be 0 to pi with the positive sin x dx, and pi to 2 pi with the negative sin x dx. So this is minus cos x with the interval 0 to pi, and here minus minus plus, so cos x with the interval pi to 2 pi, and we know cos pi is cos of pi is minus 1 and cos 0 is 1. So this is 2. Here it is again 2. So 2 plus 2 is 4 is our final answer. Read the next question. Evaluate integration minus pi by 2 to plus pi by 2 f of x dx, where f of x is sine of modulus of x plus cos of modulus of x. So here our function is sine of modulus of x plus cos of modulus of x. We should check whether it is an odd function or even function. Replace x with your minus x. So sine of modulus of minus x plus cos of modulus of minus x. So this will be sin x plus cos x, sine of x plus cos x. So this is simply similar to our given function f of x. So our f of x is even function. So in the case of even function, we can write our integration as 2 times integration 0 to pi by 2 sine of modulus of x plus cos of modulus of x dx. And in the interval 0 to pi by 2, both sine and cos are positive. So we can write 0 to pi by 2 sine x plus cos x dx. Now go with the integration. So sine x integration is minus cos x and cos x integration is sin x with the limit 0 to pi by 2. So outside we are having 2. So here while applying the upper limit minus cos pi by 2 plus sin pi by 2 minus applying your lower limit minus cos 0 minus sin 0. So this is our data. So now this minus of minus. So here it is plus. So sin 0. So now this is 2 into, here it is 1. This is again 1. So 2 plus 2, 2 into 2. Read this question. Integration x square dx divided by x square plus 4 into x square plus 9. So this can be written as x square plus 4 into x square plus 9 can be written as by taking your value y is equal to x square. So y divided by y plus 4 into y plus 9. So by considering this. So now this can be written as a divided by using partial fraction expansion procedure. So y plus 4 plus b divided by y plus 9. So now y divided by y plus 4 into y plus 9, that is a times y plus 9 plus b times y plus 4 divided by y plus 4 times y plus 9. So these two will get cancelled. By comparing the coefficients value, you can find your a value as minus 4 by 5 and b value as 9 by 5. Now go with the integration. So our integration becomes, yeah, our y value substitution. Here you can substitute your value. So a and b value. So a is minus 4 by 5 divided by y plus 4 plus 9 by 5 divided by y plus 9. Now go with the integration and also doing your back substitution. So integration of, for minus 4 by 5 you can take it outside. 1 divided by x square plus 4 dx plus 9 by 5 integration of 1 divided by x square plus 9 dx. Now you can take your value here. This is 4 is nothing but your 2 square. So minus 4 by 5 integration 1 divided by x square plus 2 square dx plus 9 by 5 integration 1 divided by x square plus 3 square dx. You can apply your formula. So here a value is 2. In this case a value is 3. So 1 by a into tan inverse of x by a formula. So minus 4 by 5 into 1 by a tan inverse of x by a plus next term 9 by 5 1 by a 1 by 3 and tan inverse of x by a plus c. So now simplify your data. So minus 2 by 5 tan inverse of x by 2 plus 3 by 5 tan inverse of x by 3 plus c. So this is our final answer. Next question is, prove that integration 0 to pi x sine cube x dx is equal to 2 pi by 3. So let us consider I is equal to integration 0 to pi x into sine cube x dx. So we are going to use the property upper limit plus lower limit minus x will be replaced for your x. So you can consider this as your equation number 1. So now integration 0 to pi, pi minus x, that is upper limit pi plus lower limit 0. So pi plus 0 minus x. So that is pi minus x. So pi minus x into sine cube of pi minus x into dx. So integration 0 to pi minus x into sine of pi minus x is sine x. So sine cube of x dx. So consider this as equation number 2. So now you have to add the equation 1 and 2. So left side will become 2i and right side will become 0 to pi. So here this term sine cube x dx will get cancelled. So pi into sine cube x will be left out item. So here pi is common. So you can take your pi outside. So pi into integration 0 to pi sine cube x dx, and this sine cube can be written as sine square x into sine x dx, and again sine square can be written as outside we are having pi 1 minus cos square x into sine x dx, and go with the substitution procedure. So here you can consider your t value will be equal to cos x, then dt is equal to minus sine x into dx. So our limits, so the lower limit value, so here in the case of x is equal to 0, lower limit value, then upper limit value will be cos 0 is 1, and your upper limit in the case of x, that is x is equal to pi, then t will be cos pi is minus 1. So now our limit will be, the lower limit is 1 and upper limit is minus 1. So here 2 into I is equal to pi times integration. The lower limit is 1 and our upper limit is minus 1, and 1 minus t square. This sin x dx is minus dt. So you can take minus outside, so dt. Now this minus can be written as, you can swap the limits upper and lower limit. So here 2i is equal to pi into integration minus 1 to 1 minus t square 1 minus t square into dt. So this integration is pi times t minus t cube divided by 3 with the limit minus 1 to plus 1. So 2i will be, while substituting our limits, our answer is 4 pi divided by 3 and we need I only. So this is 2 pi divided by 3. This is what we need in our question. So it is proved now. Coming to the next question, prove that integration 0 to, this is 0 to pi by 2. 0 to pi by 2 root of cos x divided by root of sin x plus root of cos x dx is equal to pi by 4. So now our question, let us consider I is equal to 0 to pi by 2 root cos x divided by root sin x plus root cos x dx. So this is equation number 1. Now using our property integration f of x. So upper limit plus lower limit minus x will be replacing your x. So now this will be pi by 2 plus 0 minus x. So our integration is 0 to pi by 2 root of cos of, here this can be written as pi by 2 minus x divided by, similarly in the denominator also, sine of pi by 2 minus x plus root of cos of pi by 2 minus x dx. Now cos of 90 minus theta is sin theta and sine of 90 minus theta is cos theta. So use the complementary angle formula. So now this is root of sin x divided by root of cos x, root of cos x plus root of sin x dx. So this is our equation number 2. So now you can add your equation number 1 and 2. So left side will be 2 times I. Look at your equation number 1. So in the numerator we are having root of cos x and here root of sin x. And the denominator part is same. So you can take the common denominator part. So 2I is equal to integration 0 to pi by 2, the common denominator, root of cos x plus root of sin x, and in the numerator part, in the first equation, we are having root of cos x, and in the second we are having root of sin x dx. So the entire item will get cancelled with each other. So it will be equal to 1. So integration 0 to pi by 2, 1 into dx. So this will be x with the limit 0 to pi by 2. So this is pi by 2 minus 0. So 2I is equal to pi by 2, and whereas I is equal to pi by 4. So this is our requirement. Look at your question. This you have to prove with pi by 4. So you can say hence proved. Our next question is evaluate integration minus a2 plus a root of a minus x by a plus x dx. Let us consider x is equal to a cos theta. Differentiate with respect to theta. So dx is equal to minus a sin theta d theta. And the change of limit in this case. So x will be minus a, then theta will be pi. If x will be plus a, then theta will be equal to 0. So now our integration is integration. The lower limit is now pi 0 root of a minus a cos theta divided by a plus a cos theta, and for dx this is minus a sin theta d theta. So you can take minus a outside, pi to 0 integration. Within the root take a common, 1 minus cos theta by 1 a into 1 plus cos theta, and sin theta can be written as 2 sin of theta by 2 cos of theta by 2 d theta. And here this will get cancelled. So and this minus you can change the limit, swap the limit. So 0 to pi, here it is root of 1 minus cos theta can be written as 2 sin square theta by 2 divided by 2 cos square theta by 2, 2 into sin of theta by 2 cos of theta by 2 d theta. So now here the 2 will get cancelled, and then if you are taking out of the root, then this is sin theta by 2. Here we are having 1 sin theta by 2. So that is a into integration 0 to pi. Left out items are 2 sin square theta by 2 d theta. Now this can be written as 1 minus cos theta d theta. Now a into this is theta minus sin theta with the limit 0 to pi, and for applying your upper limit pi minus sin pi minus the lower limit application 0 minus sin 0. So now final answer is a into pi. And next question, integration 2x minus 5 e power 2x divided by 2x minus 3 whole power 3 dx. So let us consider t is equal to 2x. Then our dx will be equal to dt divided by 2. Now substitute in your integration. So integration is t minus 5 into e power t divided by t minus 3 whole power 3. And here it is dt divided by 2. So 1 by 2 integration, and t minus 5 can be written as t minus 3 minus 2 divided by t minus 3 whole power 3 into e power t dt. Now 1 by 2 integration t minus 3 divided by t minus 3 the whole power 3 minus 2 divided by t minus 3 whole power 3 times e power t dt. So we know our formula. In this case, we can cancel your item. So this will be. So our data will be 1 by 2 integration 1 divided by t minus 3 to the power 2 minus 2 divided by t minus 3 to the power 3 with the multiplication e power t dt. So now you know this formula, integration e power t f of x plus f dash of x dx is equal to e power x. So e power x into f of x plus c. So now you can consider your f of x will be equal to 1 divided by t minus 3 to the power 2. That is t minus 3 to the power minus 2. So f dash of x will be minus 2 divided by t minus 3 to the power 3. So this will be equal to 1 by 2 times f of x value. F of x value is 1 by t minus 3 to the power 2 into e power t plus c. Back substitution with your t value. T value is 2x. So our final answer will be 1 by 2 times 1 divided by 2x minus 3 to the power 2 e to the power 2x plus c. So this is our final answer. Meet you in the next video. Bye.